Hey guys, here's homework solutions for 1.5. So for number 1, it says use the graph of the square root parent function to graph this one that was shifted. So inside the square root, this is where our horizontal shift is happening. We do the opposite of what it says. It says add 3, instead we're going to go to the left 3. And then it says add 1 vertically because that's outside the square root. So to the left 3, up 1. That's going to be the start. And then it's the square root parent function. So it looks something like that. That might be a little big, but you get the idea. For number 2, we've got an absolute value function. Normally looks like a v, right? But this says negative, so it should be a negative v. And then I've got a horizontal, because it's inside the absolute value, a horizontal. We can do the opposite. It says multiply by 2. Instead, we're going to divide by 2. Which means instead of going down 1 over 1, we're going to go down a half over 1, so down 2 over 1. That's what I'm trying to say. Remember, a horizontal compression is the same thing as a vertical stretch. Hard time. This isn't the smart board feature, so it's hard to get these dots to go unless they're genuine. So there you go. All right, number 3. I am very sorry, it's a bad question. It says, how does x squared compare to g of x? Where is g of x? Bad question. Sorry. My bad. All right, number 4. It says, identify the parent function. All right, when you look at this guy, hopefully you see these absolute value signs, which tells you f of x is equal to absolute value of x is what parent function. Most of you guys did really well on that quiz, so as far as identifying your parent function, so that's good. I was hoping I could change my pen. Anyway, and then it says, describe how the graphs of g of x and f of x are related. So this is where a lot of you guys did not tell me what was happening on your quiz. So first off, in my absolute values, I've got this +2. That's a horizontal shift. It says to the right 2, but I know it's going to do the opposite. It's going to go to the left 2. Outside, now we're talking about vertical happenings. 2 times would be a vertical stretch. It does exactly what it says. So it says multiply by 2, we're going to multiply by 2. That's a vertical stretch by 2. The negative 3 in the back, that's a vertical shift, up or down. Again, it does exactly like it says. It says to go down 3, so it's going to go down 3. So I'm going to start by looking for my vertex of my v. Negative 2, negative 3 is going to be the center. Be careful with your scale here. This is negative 2, down 3 is halfway between 2 and 3. And here. And then my stretch is up 2 over 1. As long as your scales are the same, you can just count up 2 over 1, up 2 over 1, up 2 over 1 this way, up 2 over 1. And try your best to make a good sharp V. There you go. For number 5, we have got a piecewise function when x is less than negative 3. So we are talking about this portion of the graph. Wow. From when x is less than or equal to negative 3, my y value is negative 1. So all the way up to negative 3, including negative 3. Pretend like that is a nice flat horizontal line. Sorry about that. All right, when x is between negative 2 and positive 2, my function is this linear function. So the slope is 1, the y-intercept is 1. So we're starting here, we're going up 1 over 1, solid circle at 2, going backwards. I would have an open circle right here, but it's already filled in from the previous line. So here we go. Solid all the way through now. And then between, oh, I see what my problem is. This would be negative 3, Miss Harris. So this is where we're solid. Over here, I've got an open circle at negative 2. Sorry. When x is less than negative 3, 1, 2, 3, Miss Harris, we have this line starting when x is negative 2, but not including, because there's not an equal sign. We have this line up to 2. And then when x is between 4 and 6, you count these out, 1, 2, 3, 4. So between here and here, I've got the step function. Remember your step function starts here, 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 here. So here we're up here, 4. And then open circle on the other end, close, open circle. There we go. There's our piecewise defined function with transformations. Number 6 is use the graph of f of x equals x cubed. We did not do one of these in class, but they're really cool. So worst case scenario, what do? You plug it into your graphing calculator. So what would g of x look like? Okay, first of all, f of x is equal, looks like, sorry, not like that, Ms. Harris, like this, roughly. But we're going to take this guy and we're going to shift it to the left one. It says to go the right one, but instead we're going to shift it to the left one. And the points. So if I didn't have the absolute value signs, that's what it would look like. And then, what does this absolute value do? It takes all of these points. If it becomes a negative point, it's going to flip it back up. So this point here is at -2, -1. And so it's going to become -2, +1. This point here is at -3, -8. So it's going to become -3, +8. So it takes any portion of your graph that goes beneath the x-axis and it flips it back up. Like that. And so you might think, oh, well, that looks like a quadratic. Well, it's kind of got more of a sharp point here than a quadratic. It doesn't have a nice U shape, I don't believe, but it might. Moving on to the next page. All right, I'm going to cut it here because the next page is word problems. So that's it for your practice problems. Tune in to the next video for your word problems.